Problem 2. A cart of mass 429 grams is on a ramp that makes an angle of 26 degrees above the horizontal. So this is about the mass of the carts that we use in class. So the numbers here that we get for newtons are reasonable for the types of forces that we work with when we work with the carts on the ramp. So following the same procedure as we did in problem 1, the first step is to draw a free body diagram. And I would recommend that you do this actually on a drawing of the ramp. It's going to make it much easier to figure out your angles. And put your object right on the ramp. Draw your force of gravity, and just a tip, it'll be easiest if you make it go all the way to the bottom. It'll be easier to figure out your angles. So we have a force of gravity and we have a normal force. And no friction, so those are the only two forces. Set up an XY coordinate system. So it's always going to be most convenient if your acceleration is either completely in the X direction or completely in the Y direction. That way, when you set up your sum of the forces equations, one of those equations will have the entire acceleration, and the other equation will have an acceleration of 0. So it makes the problem solving much easier. So the acceleration of the cart is going to be this way, down the ramp. So that means I want to set up my coordinate system actually to be tilted. And I'm going to make my positive x-axis be down the ramp, and then the y-axis has to be perpendicular to that. So the positive y-axis is perpendicular to the ramp. State force and motion models. Well, we can see that we have unbalanced forces here, so it's definitely going to be accelerating. At any point in the video, if something's not clear, be sure to stop the video and think about what just happened and make sure you understand it. Also, I'd recommend working ahead and then watching the video to see if I did the same thing that you did, because you will learn more if you are actively engaged in creating a solution yourself rather than just watching me. So I would recommend you do the next step, then watch my next step, then try the next step yourself, and so on. Okay, part B is to find the components for any forces not already aligned with the X and Y axes. So you should go ahead and try that, and then come back and check your work. Because my coordinate system is tilted like this, the normal force is already aligned with the y-axis. The force of gravity, however, is not already aligned with this coordinate system. And so that means we need to find the components of this force. We need to find out how much of it is pulling down the ramp, how much of it is pulling basically into the surface. So to do that, I need to draw components. And there are two ways you can do that, and I will draw both of them so you can see. One is to start here and go along the y-axis first. Just make sure you stop at the right point so that you can make an x component that's parallel to this axis. Don't go all the way down here, because then your x component would be here, and that's not in the x direction. So you need to stop here and draw an x component so you have your right triangle. The other way you could draw it is you could draw the x component first, so that would be going this way, and then the y component. Okay, just make sure that when you're done, your components are one that's parallel to the x-axis and one that's parallel to the y-axis. Okay, I am going to use, make sure there's arrows on your components. I'm going to use this triangle. So I need to know that angle. And you can use either triangle, you'll get the same exact components. Just make sure you use the angle for your triangle. So if this is 26 degrees and this is a right triangle, the angles have to add up to 180. This angle is 90. So that means that this angle must be 180 minus 90 minus 26, which is 64. And then these two angles have to add up to 90, so that means this angle must be 26. Okay, finding components. Cosine of 26 degrees equals something, and then sine of 26 degrees equals something. Cosine is adjacent over hypotenuse. And I'm noticing I did not label my components. So this is the component along the y-axis. So I'm going to call this FGY. This is the x component, so this is FGX. So adjacent to my angle is FGY. The hypotenuse is the force of gravity. Oh, now this is interesting. I do not know the force of gravity yet, so it looks like I need to calculate that. So let's just go over here and find the force of gravity. The mass is, make sure you put it in kilograms, 0.429 kilograms times 9.8 newtons per kilogram. So calculating that, we get 4.2 newtons. So now I can continue over here. Cosine of 26 degrees is FGY over 4.2 newtons. So calculating that, we get 4.2 times cosine of 26 is 3.77 newtons. Okay, and that is in this direction. And I'm going to take the direction into account when I actually put it into my sum of the forces equation. So for now, this is just fine because I'm keeping track of my direction here. Okay, let's find the other component. Sine of 26 equals opposite over hypotenuse. Opposite my angle is FGX. Hypotenuse is the force of gravity. So substituting my force of gravity, I can solve for FGX, which is 4.2 newtons times the sine of 26. So using the calculator, we get 1.84 newtons. Okay, those are our x and y components of the force of gravity. So now remember, we're basically replacing this force of gravity force vector with the two components, and we will now just use those components in place of this vector. Part C, set up the sum of the forces equals MA equation for the x and y directions. So sum of the x forces and sum of the y forces. And at this point, you don't even need to know what you're looking for, because together these equations will enable you to find all of the forces if you were given enough information. So the sum of the x forces, I only have one x force. It's this x component of gravity. So that's FGX, and that's in the positive direction. And substituting what I know that the x component is 1.84 newtons. I know the mass is 0.429 kilograms. And it looks like I can find the x direction acceleration, which is the only acceleration it has because it's not accelerating up and down from the surface of the ramp. So calculating that, we get 4.3 meters per second squared. Okay, let's see what we can find from this equation. The sum of the y forces. I have two y forces. Fn is upward, Fgy is the opposite direction in the negative y direction. So I would have Fn, okay, all of my positive direction forces, minus all the forces in the negative direction. What's the y direction acceleration? That's going to be 0 because the vertical forces are balanced. So substituting what I know, Fgy, that's the y component of the force of gravity, which was 3.77 newtons. So the normal force equals 3.77 newtons, or 3.8, being a little more careful with the significant digits. So let's check and see if we found everything we were looking for. The problem said to find the acceleration of the object and all unknown forces. So we have the acceleration right here. We did not know the normal force. We have found that here. And we did not know the force of gravity, but we have found that here. So we have completed the problem.